All right. Good evening, ladies and gentlemen. Let's get to it. 512, how high will it bounce? Rebounding ratios. Many games depend on how a ball bounces. For example, if different basketballs rebounded differently, one basketball would bounce differently off a backboard than another one would. And this could cause basketball players to miss their shots. And if you've ever played with an overinflated basketball, you know how different it is than a regular basketball. For this reason, manufacturers have to make balls' bounciness conform to specific standards. For this lesson, you will investigate the relationship between the height from which you drop a ball and the height to which it rebounds. Okay? We are going to do this in class. We're starting tonight. We're going to finish it tomorrow in class. Tomorrow it's going to be kind of interesting. We're going to give it a shot based on the COVID things. It's going to be a challenge, but hopefully it works out pretty well. Okay? So 518. First problem. 518. Listed below are bounciness standards for different kinds of balls. Tennis balls, and you are going to take some notes here. So write 518. Here's what I want you to write down. Tennis balls, they must rebound approximately 111 centimeters when dropped from 200 centimeters. Okay. Soccer balls must rebound approximately 120 centimeters when dropped from 200 centimeters onto a steel plate. That's interesting. Why a steel plate? Well, if you try to bounce a ball on different things, you'll notice that they bounce differently off different things. Like, for example, on grass versus on pavement or concrete or steel, they would all bounce differently. And so by picking one specific thing like a steel plate, it kind of standardizes that to where, oh, well, it bounced okay on grass, but now it bounces too much on the steel. Okay, so they just picked one thing. Basketballs must rebound approximately 53 5/10 inches when dropped 72 inches onto a wooden floor. And wooden floor makes sense because basketball courts mostly are wooden. And then last but not least, squash balls. And if you've ever seen squash, it's an interesting game. I think I've played it once. It's very similar to racquetball. If you want to, you can pause and look at squash at home. If you were here in class, I'd probably show you a video of squash, but you're not, so I can't. But anyway, squash balls must rebound approximately 59 5/10 inches when dropped from 100 inches onto a steel plate at 70 degrees Fahrenheit. Now, what is up with steel plate? We understand, okay, to make sure it's universal. But 70 degrees, what's up with that? Well, if you play basketball or soccer or any type of sport and you keep that ball in the garage and you played with that ball over the summer, and it was fully inflated and perfectly good, if you went out to your garage right now and went to those balls, you would find that they were all flatter or flat. Maybe not fully flat, but not as bouncy as they were. Why? Because of the temperature. Now, yes, if you have a hole in the ball, that's going to affect it, but it's because of the temperature. Cold air contracts, right? And therefore, a ball that was perfectly full in the summer, if left completely untouched over the winter, if it got cold, it would shrink. Okay, that's the same with car tires. Now, right now, we're not really concerned about your car tires, but later on, whenever you do get a car or you drive your parents' car, you'll notice that over the summer, once it gets really cold, all the tires will need to be refilled. Why? Because they've lost some pressure because the air has shrunk. Okay, so they're just kind of picking the universal standard at 70 degrees. Okay, so your challenge right now is tell me which one of those four balls is the bounciest, which one bounces the most. Got it? So I want you to think about it for a minute and try to determine, do whatever math you need to, do whatever figuring out you might want to. You got a couple minutes right now. When you are done, when you think you've got the bounciest, when you think you've determined the order, which one's the least bouncy? Okay, give it a guess first, and then do some math and try to figure it out. And when you've got it, unpause the video and we'll check to see if you're right. Go. All right, here we go. Let's find out. Now, which one do you think is the bounciest? What did you do? How did you figure it out? Let's compare the first two, tennis balls and soccer balls. Now, these are kind of easier to compare because, check it out. They're both dropped from the same height. And so you could just look at how they rebound and say, oh, well, look at this one. This one, the soccer ball, bounces 120 centimeters, whereas here it only bounces 111 centimeters, so the soccer ball bounces more than the tennis ball. And if you wanted to, you could turn this into, you could even turn it into a fraction or a ratio and say it rebounds 111 out of 200 or 111 200ths. Okay, so that you could turn it into a ratio and say that is my fraction or ratio. And then when I compare that to the bounciness of the second one, well, 120 over 200 is bigger than 111, so therefore it has a higher rebound ratio. Now, problem is then you get to basketball and squash balls, and they've got different denominators, don't they? They were dropped from different heights, and that is going to make it harder to compare. Now, yes, the squash ball, you're like, well, 100 inches and 29 and 5/10, so I can do that fairly easy, right? If I turn it into a fraction or a ratio over 100, well, just doubling that would give me 200, right? But what about 72 inches? How are you going to do that? Well, the cool thing is you can still do it. You can now, yes, I know it has a, look at this, it has a decimal within a fraction. I understand that's not always ideal. So can you get rid of it? Ooh, and finding a common denominator for 72 and 200, can you imagine that? That would be a nightmare. So what other thing could you do to kind of simplify these ratios? And by the way, please make sure you've written down these ratios by them, okay? This should lead you pretty closely to determining. So what could I do? What if I change them to decimals? Or you could even change them to percents, right? If I change them to percents and say, what percent of its drop will it rebound? That's going to make it even easier to compare. So, for example, the first problem at the top, 111 over 200, if I go ahead and do that division, I get 555 thousandths, or roughly 56%. Now listen, this number here, when you put it in your calculator, which by the way, do it please right now, please do 111 divided by 200, do it. When you do that, you get 555 thousandths. If it just stops, if it terminates, if it is a rational number, meaning it has an end, then write the number, okay? I want you to write all of that number, this whole thing, okay? Don't round unless you have to. Now, when I go to percent, we'll round that to 56%, that's fine, okay? Now, please go ahead and do the rest for all three of them when you are done filling out those numbers for all three of them. Then go ahead and unpause the video and we'll verify our numbers, okay? Go. All right, so here for this one, you should have gotten 6/10 or 60%. Okay, for this next one, 53 and 5/10 divided by 72. For this one, this is an irrational number, so I do want you to round here. And we can round to the nearest thousandth, right there. Or 74%. And then this last one here, oh, well, actually, you know what? Hopefully, you feel pretty comfortable doing that. 29 5/10 divided by 100, you smooth the decimal point twice, or 30%. So ladies and gentlemen, which one of these balls bounces the most? It is by far, clearly, the basketball is the bounciest of all four of those balls there, okay? The least bouncy would be the squash ball, because when you drop it, it'll only rebound 30% of its drop height, okay? That's what this claims, okay? 30%. Whereas the basketball rebounds 74% of its drop height. That's pretty good, okay? All right. Next problem, 519, the bouncing ball. How can you determine if a ball meets expected standards? Okay, this is what we're going to do in class tomorrow, but I want you to start thinking about the process today. With your team, find the rebounding ratio for a ball. Your teacher will provide you with a ball and a measuring device. You will be using the same ball again later. Probably not, unfortunately, because of COVID. So let's move on. Before you start your experiment, discuss the following questions with your team. Here are the questions I want you thinking about. What do we need to measure? How should we organize our data? And how can we be confident that our data is accurate? Those three key questions right there. This is what you're going to take notes on for this problem. So please write down problem 519 on your book, in your notes, 519. And what you're going to do is you're going to think about it. Tomorrow in class, I'm going to give the students here in class a ball and a measuring device. And those of you at home, you are going to go, I'm going to split you up with those groups. So I might have 2 students in class with a ball and a measuring device, and 5 or 6 or 7 of you at home in a group following along with those 2 students as you work through doing this, okay? And each one of you will be in a group, each one of you will be paired up with someone in class, and you are going to determine the bounciness of a ball, all right? How? What are you going to do? How are you going to figure out that process? How can you make sure it's accurate? How are you going to organize your data? I want you to write right now about 3 to 4 to 5 or 6 statements, however many it takes. Statements from 519 saying, here's how I would run my experiment. Okay? And if you think something simple like, if you think something simple like drop the ball and measure how high it bounces, that is way too simple. There's a whole lot more to it than that, okay? So I want you to think, and I want you to write 3 to 4 to 5 or 6 statements, whatever, specifically stating how you would measure the bounciness of a ball, okay? By the way, possible things to think about. How high should you drop it from? Should you drop it from just one height? Should you drop it one time, multiple times, different heights? How should you drop it? How are you going to measure it? What are you going to do? There's a lot that goes into this thought. So you're going to write 3 to 4 to 5 or however many statements. I am going to ask several of you to read it in class tomorrow. So it might be people in class, it might be remote, it might be whatever. Be ready, okay? How are you going to measure it? And that's what we're going to discuss. So that is your homework right now, is to write certain number of statements, some statements. Really think about the process, really think about how you do it, and then we're going to try out some methods tomorrow. Got it? All right. Have a great day. We'll see you tomorrow.